Okay, this is a video for car guys here. Today I want to talk about piston engines and I believe the hot rodders are really going to like what I'm trying to tell you here. So I want the car guys and I hope you'll be honest what I'm telling you about poison gas emissions and stuff like that. You can figure it out. You can talk to me. I'll talk to you about it. People don't want to say this, and I don't know why it's so hard to tell the truth. But think about your four-stroke engines. Out of the four strokes, one of the four strokes is a power stroke, and you got three parasitic cycles: compression, exhaust, and intake. These are not the zeros. They're less than zeros. Takes power to pump this air, to pump it in and out. Takes power to compress it. Takes power to the exhaust. Think about, there's a lot of pressure in the engine and the piston's having to push it out the exhaust valve. Even the intake cycle, sucking air in, you know that. So a four-stroke engine cannot be more than 25% mechanically efficient. If we believe force times distance equals work, then that's a basic formula of physics. And then, even then, if one of the four strokes is 25%, but you also have connecting rod angularity, the piston is not always pushing on the crankshaft at the most advantageous moment. A good angle, the angle is bad, so you're going to reduce the force that's transmitted to the crankshaft by some degree. The Department of Commerce says that the average engine, the four-stroke engines average 6 to 10% fuel efficiency. 6 to 10% of the fuel is converted to work. And we also know that four-stroke piston engines never convert more than 20% of the fuel's energy to work. So this is really poor. But it's all we got. We're used to a Ford and a Chevy, and we could argue, is that better than a Hemi? And probably not, but we're not getting the big part where there's three parasitic strokes and there's only one power stroke. And it's not even very mechanical, but it runs. It also pollutes, and we're running it on dead dinosaurs. Come on, guys. These are even low energy fuels, so even diesel. So, and I know alcohol has less energy but can make more power because you can burn more of it. It has oxygen in it. I am a car guy, and I believe this is something car guys are going to like. The hot rodders. We're talking about 100% power cycle for the engine. We don't care if it pollutes or not when we're hot rodders, but maybe we do. We like breathing, and nothing is wrong with that. So, I hope the car guys will watch what I'm doing here and pay attention. This is really my core audience, the way I see it. I'm not the tree hugger guy. I'm just telling you the truth about putting oxygen back in the air with hydrogen peroxide and how much air a gasoline engine uses to burn a gallon of gasoline. So, I'm wearing my Bonneville shirt today. I got two or three of these. My brother gave me this one. He brings me a shirt from Bonneville, which is not near as good as getting to go to Bonneville, but that's where I'm trying to head. They have a Omega class for a non-auto cycle engines. And I believe those are going to be a lot better. We're going to be thrilled with these kind of motors. They're a lot simpler than piston engines. I believe mechanical efficiency translates directly into thermal efficiency. The more efficient mechanically the engine is, it's going to make better use of the fuel. These two things are related. Here the car company engineers talk, you'd think that no relation between thermal efficiency and mechanical efficiency. That's the dumbest thing I ever heard. So anyway, all you guys, if you're a drag racer or Bonneville guy, or if you just like engines, if you're just a tune-up mechanic, I hope you'll hear me. But mostly, if you know what valve cover, if you know what car, this valve cover, I can tell you this is the original Top Fuel engine right here. If you can name the car that this valve cover came off of, this Chrysler Firepower Hemi valve cover with these bolts, you are a hot rodder, and I hope you'll give me a call. So, thanks for watching, and keep watching. It'll give